Hello again. Next up, it's my absolute pleasure to be introducing you to our next speaker, Ravi Hulasi, Chief Cloud Evangelist, Tamr. Over to you, Ravi.
Thank you, Louisa, and good afternoon, everybody. Just going to share my screen here, and then we can get started. Wonderful. Well, thank you, everybody. Hi, my name's Ravi Hulasi, and I'm the Chief Cloud Evangelist at Tamr. I'm here today to introduce you to Tamr and show you how we've helped a number of companies improve the quality of their data as they've migrated to a cloud environment. First, we'll discuss the need for data quality to enable business outcomes and how it doesn't have to be an arduous task which slows down a cloud migration project. In fact, we'll show you how using the cloud as a location to perform this task can be quite advantageous, especially as it opens up a new set of opportunities to manage your data in a more modern manner. And we'll also put some case studies up to share with you from a global insurance company and an airplane manufacturer, where many of these topics have been put into action. So here we are in 2021, and organizations are still struggling to leverage their data as an asset. Many have invested significantly in analytics programs, and the software for BI and analytics visualizations has reached maturity, but the reality doesn't really match the vision, and data continues to be the problem. And so as internal and external data sources grow exponentially, organizations have been unable to keep up with volume and high variety of data. These data silos contribute to messy, duplicate data that is incomplete and inaccurate, making it impossible to make meaning from their data. Throughout the years, companies have tried to break down their data silos with technologies like data lakes, warehouses, and MDM. MDM in particular has aimed to solve for creating clean golden records of data, but often the rules-based approach taken has failed to bring together data from those internal and external sources as the enterprises scale. And so this has created a huge sunk cost in maintaining these rules. Many of our customers have invested millions of pounds, dollars, euros on these solutions, including the highly skilled resources needed to build and maintain hundreds of thousands of rules. And as a result, data-driven projects take years, and many of them fail to get off the ground. So what does this all mean in the context of a cloud migration? A migration is a perfect opportunity to deploy Tamr to solve data quality problems found in on-prem legacy data silos and avoid the lifting and shifting of these issues into a new environment. Tamr's mission is to identify these underutilized data sources and make them fit for use. These sources could be systems such as ERP, CRM systems, homegrown databases, or even external enrichment data sourced from third-party providers. We process them into a set of rich, mastered datasets representing a wide variety of entity types, such as customers, products, or securities. To do this effectively, we use machine learning to accommodate the data scale and variety while gathering human feedback along the way from internal subject matter experts in order to refine the process and gain trust in the output from those who will be consuming the data. These curated datasets empower your teams to answer business questions such as, how do I improve upsell opportunities at my biggest customers? And they can have confidence in their answer since they're using the most accurate, up-to-date data available to them. All of this takes place using cloud-native components from the top 3 cloud vendors. The result is a much faster and smarter migration to the cloud. And since data is always changing, this process can be deployed as a reusable pipeline, reading data on a continuous basis and publishing it into a known location for consumption. This ensures that once your data is clean, it can stay clean. So I've set the stage for why mastering your data is important when considering and planning your migration to the cloud. Now let's take a look at when in the migration to do this task. Now there's many workflows out there and frameworks for migrating applications to the cloud. And here's one from Google, which I'm going to use as a basis for this discussion. And so often you start by taking stock of an application, who uses it, and how it's architected, especially regarding the data sources in use. From there, you may start to develop a plan for migration and establish priorities and timelines for when things will get done. Now, a lot of the heavy lifting comes in the data movement phase, and often this is focused on the physical movement of data into a landing zone in the cloud, or sometimes making use of products and services provided by the cloud vendors or by third parties to accelerate this transfer. For example, offline disk imports, database dump utilities, or even streaming to persistent disks. Now, once data has been moved, along comes the need to move the application itself. And this is where many of the R's of cloud migration come into play. So you have rehosting, lifting and shifting, replatforming, such as moving from an Oracle database to a Redshift database on AWS, refactoring applications using cloud native services. And I've also included at the bottom the options to retire, repurchase, and retain, or do nothing. And once that movement of the application has completed, now comes the time to optimize. And this is where the fun really starts, and you can start to take advantage of all the benefits of the cloud. So for example, you might want to add redundancy in the form of availability zones, elasticity with auto-scaling groups, or migrate to a serverless model to keep on top of costs. If we examine the data movement phase, this is an ideal time to consider mastering your data, as the data needs to move to the cloud anyway. So you may have heard thoughts about whether to do this before or after moving the data. And there's actually a commonly used analogy around cleaning up your house before moving to a new one, so you don't spend time packing and shifting the stuff that matters, so the stuff which matters only. And so let's take a look at how this can play out. So if we take that approach of cleaning everything before we move it, well, this would involve setting up a mastering process close to your existing applications and your data prior to transferring the mastered data to the cloud, where it usually ends up on a data lake. And then once in the cloud, there's probably some additional movement of the data before it ends up in its target destination for the application to consume. So in other words, you'd be building a new mastering workflow on-premise. And so these processes would master the data being received from each individual system. And so they'd only have visibility to the data currently presented in the existing source systems. And this affects how complete the master data can be in terms of reach. So for example, a customer master built on the data from system A may still not consider customers present in system B. And so for all the effort you've put into developing and deploying a mastering process, it's of limited reach, residing in an environment which is going to be decommissioned and doesn't have much scope for reuse. So instead of putting that effort into deploying a mastering process on-prem, what if we were to focus on mastering the data once it's been transferred to the cloud? And so here's what this view looks like. The key difference here is that now we're mastering data once it's reached that staging area in the data lake. And this gives us the ability to create a much more complete master, utilizing data from many more systems. And the result is a much more comprehensive view of mastered entities, which can then be deployed to the destination applications of your choice. Now, a key benefit of this approach is not only the increased scope of the master, but also in the mastering pipeline itself. As it's being deployed in the cloud, it can be reused with new data as it arrives at the cloud data lake. And by making use of cloud native services, it can scale to accommodate your data volumes now and in the future. Looking back at our list of migration phases, we can add a new phase parallel to data movement where the mastering takes place. One additional benefit of mastering multiple sources at a time is the ability to perform analysis of the data to understand which sources are actually being used in constructing that golden record. And so this can be especially important when considering which sources to retire as now you can generate metrics on overlap and redundancy. The cost benefit of retiring a data source can be quite considerable, especially if the source is one which is being purchased from a third-party data provider. So I've added another phase to the flow here, and you may be wondering, well, how do I get the time to master my data with all these other tasks to accomplish? And this is where Tamr comes in. So now we'll take a look at how Tamr leverages cloud-native services to scale machine-driven data mastering effectively. Before we talk about our use of cloud infrastructure, let's spend a few moments talking about our approach to mastering data. On the left, we have traditional MDM solutions which require thousands of person-hours to generate, manage, and tune complex rule sets for mastering data. Tamr's technology and our approach is based on our core belief that machines do some things incredibly well, but that human expertise is irreplaceable. When combined together in the right way, they can solve a class of data integration challenges that were previously deemed too lengthy or too difficult to tackle. So on the right is our data-driven approach, which centers on requesting feedback from subject matter experts within your organization on machine-generated recommendations using actual examples from the data. The result of this approach is a much faster time to value, which opens up the possibility of delivering use case ready data in days to weeks instead of months or longer, as well as enabling underutilized internal and external data sets to be used to their full potential. With traditional systems, complexity in building and maintaining rules grows exponentially as new data sources are onboarded and the rules have to be modified to adapt to the new data conditions. And so some organizations try to maintain hundreds or thousands of rules, which are brittle and quickly fail when these new data sets are added. Today, machine learning makes solving the toughest data mastering challenges a scalable problem. And for many of our customers, Tamr is able to master tens of millions of customer records in a matter of weeks. The machine learning process gets smarter over time by learning from additional data points, which means that Tamr becomes more cost-effective for you as you add more sources. What's more, it only requires a few resources to maintain, as opposed to dozens of highly skilled resources required to engineer traditional rules-based systems. So here on screen, we can see the core capabilities of the system, each of which combines our approach of using machine learning and subject matter expert input to achieve the best possible outcome. We provide a modern data management ecosystem with essential functionality such as data mastering, enrichment, publishing of curated, logically grouped datasets, and intuitive workflows to engage business users in data quality initiatives at the point of consumption in applications such as Salesforce or Tableau with an embedded widget. Tamr delivers these next-generation approaches to data mastering in a modern data technology stack comprised of RESTful APIs that sit on top of proven cloud-native services from providers such as Google Cloud, AWS, and Azure. The result is that the Tamr system now helps organizations to dramatically accelerate their ability to leverage data as an asset in their analytic and operational use cases, while significantly reducing the manual workflows required to master enterprise data at scale. So let's take a closer look at the core capabilities of the system, each of which relies on our approach of using machine learning and expert inputs to achieve the best possible outcome. We'll start here with schema mastering, which combines disparate data sources through a process that leverages machine learning and the expert input to effectively and efficiently align columns in the data sources into a master schema. Many of our customers in the pharmaceutical sector are combining thousands of clinical studies with millions of columns into a single unified schema using this process. Now, performing this sort of alignment at that scale is really beyond the limits of what humans can do alone. And so Tamr's approach has enabled a vast majority of this work to happen automatically. Moving on, we have record matching, where we take large-scale disparate data sources using active machine learning to quickly generate a single, trustworthy, unified, unique view of an entity, such as a customer or a supplier. Customers of ours, such as Toyota Motor Europe and Scotiabank, are using Tamr to combine many data sets with extensive duplication and overlap, resulting in tens to hundreds of millions of clean, clear, complete customer, supplier, and parts records. Think of it as agile data mastering without all the heavy MDM overhead. Record mastering then consolidates clusters into golden records, unifying each entity into a single representation for use in downstream systems. In combination with Tamr's powerful record matching, golden records provides the complete, accurate data required to help your organization truly understand customers, suppliers, or other entities. Categorization maps records to taxonomies to facilitate understanding and analysis. So Tamr can utilize industry standard taxonomies, ones generated by other systems, or can suggest a taxonomy based on a combination of machine learning and expert input. It's here that our work in procurement analytics with customers like Societe Generale, Johnson & Johnson, and Carnival have really played a major role in powering analytics to tame spend. And so the output from Tamr is clean, curated version data that powers a host of downstream uses in a repeatable manner. And so if we examine how machine learning techniques are used when mastering data, there are some significant advantages to using the cloud as an execution environment. So firstly, these workloads can have a significant computational overhead, at times approaching an n-squared problem space. The ability to allocate ephemeral resources is critical in order to be able to perform this in an expedited and cost-effective manner. With data residing in the cloud, in a data lake or in a staging area, it's important to bring these capabilities close to the data in order to reduce latency. Many successful projects start by focusing on one key entity and using that as a springboard for further expansion. This can lead to a rapid increase in input data sources, both internal and external, which leads to a rise in data volumes being processed. It's important to be able to capitalize on this momentum without being bottlenecked by a lack of local data center capacity. And finally, we see master data as a foundational capability upon which many consumption patterns can be built. This position is further enhanced by the suite of services available in the cloud that cover the whole data management lifecycle. And these services continue to expand every day, with more offerings being added. And so, although customers may be starting on their cloud journey today and not using all these services, the rapid rate at which they are developed and released means it's critical to have a set of data that's considered trusted and a clean source of the truth, especially when using them as an input into processes, such as advanced analytics or predictive modeling. So now I'd like to talk through a couple of case studies of Tamr in action with the context of a cloud migration. Firstly, here's a recent customer mastering engagement with a leading US-based insurance company. And they had recently embarked on an initiative to improve their customer marketing efforts by making better use of external enrichment data. This required constructing views of their customers at the individual, household, and organizational levels, and matching them up with referential data sourced from a wide variety of external data vendors. And in addition to using the data for marketing, it also allowed them to evaluate themselves for regulatory concerns, such as racially biased pricing. Their existing system was using a legacy rules-based approach on-prem, which was proving difficult to accommodate new sources and be extended. Problems were occurring both in terms of the data variety, because the rules were embedded into their code, as well as the data volume, where performance had run into reliability issues due to the scale of data exceeding 300 million records. And this led to the need to carefully monitor the production deployment, as failures frequently occurred. Now, since they had a moratorium on any new services being deployed into their on-prem data centers, they wanted to refactor their process to take advantage of cloud-native services. Internal prototypes had been constructed by their data science team, which received buy-in for a machine learning-based approach, but there was also the goal to empower other teams to be able to provide feedback to the models being developed. A key part of the design of the new deployment was to make full use of the customer's cloud infrastructure in order to provide additional performance gains in a budget-friendly manner. Tamr's solution was an ideal fit for this use case. The team was able to take advantage of Tamr's platform to establish matching models at multiple levels of granularity. And the ability to assign subject matter experts items to review offered the opportunity to improve the performance of a model and gain trust in its output without having to write code to apply their matching logic. And rather than consider the integration of new sources as an onerous task, they can now be onboarded in a more agile manner, with previous learnings applied to reduce the integration time and cost. The Tamr solution is deployed natively in the customer's AWS cloud environment, which brings cost savings by making use of ephemeral resources for the compute tasks that are performed whenever data is refreshed. In addition, the deployment was able to be scaled from a small instance used for initial development and prototyping through to a more substantial footprint as data volumes increased. The net result of this is that the customer now has a platform to reliably provide data to support their analytics needs today and can grow to accommodate new sources while maintaining a robust matching process that is trusted by those consuming the data. On to our second use case. This is regarding a leading airplane manufacturer. And this migration can be considered a re-platform since they've been a Tamr customer since 2018, recently renewed their contract and will soon be deploying our solution in their Google Cloud environment. This customer's use cases are mainly focused on mastering supplier and customer data. Clean, accurate data in their customer golden records allows them to improve marketing campaigns and boost upsell opportunities by an estimated $10 million. And improved supplier golden records will drive an estimated $17 million in cost savings by providing an accurate view of key suppliers for better contract negotiations and inventory management. Given the millions of data entities involved, a manual rules-based approach just wouldn't scale. And so utilizing the capabilities of Google Cloud, along with machine learning powered by Tamr, will provide faster time to value and help them bridge the gap between the data and the analytics they wish to ask of them. Now, having worked with dozens of Global 2000 customers on their data and analytics initiatives, Tamr sees consistent patterns of key principles that are in stark contrast to the traditional single vendor, single platform approaches that are advocated by many vendors. These principles can be wrapped up into a methodology called data ops, which describes how people, process, and tools need to work together to deliver successful initiatives. So let's take a look and see a bit more about what that means. Historical attempts to unify data in the enterprise have often fallen short due to fundamental problems, but there are clear solutions defined by these principles. First and foremost amongst these principles is agility. Data initiatives should seek to deliver value to customers quickly and support rapid iteration to improve and adjust what has been delivered. After an initiative has delivered its value, it needs to embrace continual change, changing data, changing needs, changing tools, and so on. Only by embracing change can a valuable initiative remain valuable. For those initiatives to scale, they need to embrace the complementary roles played by humans and automations. Humans are the only ones who can judge whether the data being delivered actually meets their needs, whereas machines need to take that feedback and apply it at scale so that all the delivered data meets their needs, not just what has been reviewed in detail. Many vendors and users have bought into the shortcut of a single vendor, single platform solution for managing data. It's critical to recognize that no one vendor has all the answers. So creating a comprehensive data ops ecosystem requires embracing open and closed source tools from multiple vendors, loosely coupling them through standard APIs and schemas. And to be cost effective, technology should be pay-per-use whenever possible and support distribution across many modest commodity systems. Use of commodity resources means there are no surprise bills, and scale out means there's a smooth trade-off between price and performance. Data ops enables organizations to take a more measured approach to managing their data centrally and allows users downstream to either grow faster through cross-sell or upsell, optimize spend, direct or indirect, or reduce risk, which improves compliance. A classic example in data ops for compliance is know your customer in financial services. When an organization does curation well, your data truly becomes an asset and a product that is delivered out to the users, who are the employees and consumers of the data. In this sample reference architecture, Tamr's core competencies are highlighted in blue, but let's go through a few of the key components overall. So we have catalog tools on the left and their associated crawlers, and they enable large enterprises to answer the simple question, what data do we have? Movement tools like Azure Data Factory, Google Data Fusion, and AWS Glue provide high performance movement and orchestration to synchronize data across multiple repositories, each of which supports multiple consumers and objectives. Data mastering, quality, and enrichment tools such as Tamr create consistency across datasets. They need to be strongly rooted in human feedback amplified by automation in order to address the unique challenge of providing data quality at scale. Modern storage and compute platforms like S3 and Databricks support elasticity to keep costs down and interoperate with a wide variety of tools and vendors. And on the back end of this, publishing tools ensure that data is available to the intended consumers. These could be consuming applications such as Azure Purview, and this provides essential versioning and metadata to ensure that such downstream applications are using the most complete and up-to-date data. Throughout all this, feedback is really important as it ensures that data consumers are able to realize the intended benefit from their data initiatives. These consumers need a mechanism that can get their feedback back up into the data pipeline and all the way back to the sources so that the data can be continually improved over time. Knowing who's using the data also allows for feedback to be directed to the appropriate audience. Governance is required for data initiatives to be successful. Respecting data privacy and regulatory compliance at scale requires governance to be an automated, reflexive part of a data ecosystem, making governance a reliable facet of every incremental delivery. Taken together, these principles guide people, process, and tools to work together to ensure that data initiatives can deliver value quickly and can sustain that delivery over time. Now we'll do a quick tour of Tamr's core capabilities around record mastering and data enrichment. Record mastering involves correctly identifying references to key entities, then assembling information from all those references into golden records. This capability is designed to work with any entity type, such as suppliers, customers, parts, locations, etc. The process starts with one or many datasets that may differ in size, structure, and semantics. Tamr brings together all this data into a workbench where your in-house subject matter experts provide examples of records that may look dissimilar but do refer to the same entity, and also of records that may look similar but refer to distinct entities. The system uses an iterative process to learn from these examples how to gather together or cluster the data about each entity. Once all the data has been clustered into entities, the best data in each cluster can be gathered into a golden record for each entity. This generally includes foreign keys back to the corresponding entity in each of the source systems. This highly curated, consolidated dataset is then published into your lake or warehouse, where it can be used for high-impact analysis, for reliable operations, and to improve the data in source systems. Tamr provides a broad suite of capabilities to facilitate record mastering at scale. All of these are elements of a machine learning-powered workflow where subject matter experts are providing examples to the system, and the system uses an iterative process to learn from those examples. The system creates and manages a persistent identifier for each entity. Survivorship for these identifiers is automatically managed, but as with all aspects of the system, there's an opportunity for hand curation to take place and to provide feedback to the system. In addition, each entity can have a golden record constructed to capture the best information about that entity available across all sources. And the persistent identifiers are used in conjunction with identifiers from the myriad of source systems to create and maintain record linkage across all your systems, providing comprehensive visibility into the ultimate sources of information available on each entity. This workflow can be run in a repeatable manner, with changes tracked over time and highlighted to the user for feedback. Multiple subject matter experts can collaborate on the end-to-end record mastering workflow, both to divide up the work and to provide multiple views to support a single decision. A curator can coordinate activity across these many experts to shepherd projects to rapid delivery of value. Validation and review are also critical elements of trust in any data initiative, so we provide both automatic and manual review options for subject matter experts and curators to validate results prior to publication. Tamr offers built-in data enrichment capabilities, including third-party enrichment services, such as address validation using data from postal authorities, phone validation through data from phone carriers, and URL enrichment through search engines such as Google and Bing. We can also offer Tamr-developed data standardization capabilities, including normalizing the fields and values such as country codes to ensure consistency. Now, many enterprises are increasing the amount of geospatial data that they capture and process. And to support use cases with this data, Tamr has support for data originating from geospatial information systems. For example, the record mastering process can take advantage of characteristics such as distance, overlap, and diameter when learning how to identify entities. This means that when you are matching locations, you're not just relying on an address, but you can also take into account the lat-long coordinates of a point or a polygon or a path. The user interface has been augmented to display these geometries on a map to aid subject matter experts in making decisions when running training or curating workflows. And overall, these enhancements make Tamr a powerful tool for integrating geospatial information across multiple sources to create highly curated datasets to power analytics and operations. And so you can see on this example here, on the map, there's actually two representations of the same location. One is actually the boundary of the building, and that's from one data source. And then from the other data source is just a point showing the middle of that location. So Tamr is able to reconcile these multiple representations of the same location into one entity. And so as we wrap up, I'd like to leave you with some thoughts on how to get started with what we've spoken about today. Firstly, I'll say that new opportunities for data consumption in the cloud will put additional pressures on your data. And so to ensure early success and buy-in, it's important to address data quality as part of your migration strategy. Data quality does not need to slow down your migration to the cloud, though. Get data to the cloud data lake as soon as you can, so that you can build a more comprehensive entity master. And make use of the data movement tools provided by each of the cloud vendors and by third parties to help you do so. Many people have migrated similar systems to you, so take advantage of their experience and expertise. The cloud's a great location to master your data, both today and tomorrow. So take advantage of cloud-native solutions such as Tamr to overcome scale and variety, but also make use of tools like catalogs and crawlers in the cloud to arm you with as much information as possible. And by doing this, you'll be set up with curated data that can be considered foundational for future success with future consumption patterns that have yet to emerge. And with that, I'd like to thank you for your time today. I hope you've learned some approaches to improving data quality as part of your cloud migration, and also understand that it's not necessarily an onerous task. So I wish you good luck in your migrations. And if you'd like to learn more about Tamr and how we can help you on your journey, please feel free to contact me. And I'd now like to pass it off to Larissa for some questions. Thank you.
Thank you so much, Ravi. Yes, actually, we have a few questions. So we are debating whether to build an MDM solution in-house or buy one that's cloud native. Why is buying better than building?
Thank you, Louisa. I think it comes back to that discussion around the best of breed workflow. If you look at building a true master, there's a lot of different steps involved, and that's even without considering the overall approach and advantages of machine learning. So what we've often found is that, especially with our first use case, the team there had built some machine learning processes to tackle that part of the problem, but still had the overall workflow to concern themselves with. And so using a best of breed application, buying one in, allows you to solve that problem in one fell swoop and abstract yourself away from it. Especially nowadays where customers are focusing on their core business activities and making use of external service providers to cover back office functions. In a similar way, many people used to have their own email server, their Lotus Notes 123 server, Lotus Notes server running on-prem, and now it's outsourced to Office 365 or G Suite. So in a similar manner, buying in a service that covers the whole solution can allow for rapid time to value and a high quality output.
Thank you. So your recommendation is to master data once it has all been moved to the data lake. What happens if there are some source which I don't want to co-mingle within a master?
Okay, thank you. So if I understand the question correctly, it's my advice has been, let's master everything in the cloud, in the data lake, but there are some systems which you may not want to master together and have them as an output of the golden record. So my advice in that case is still to perform the mastering in the cloud, but take advantage of the metadata that's present. So for example, there may be some data being captured with a consent flag, a consent management system has been applied to say, do not use this data for marketing. Okay, great. So we're going to use a mastering process and we're going to create that mastered set of clustered records. But when it comes time to building out the golden record, we can actually build multiple golden records for different consumption targets. And so when we come to build the mastered golden record for marketing, we can respect that flag, that metadata to say, build this golden record, but do not use any of the fields or values where consent has not been given for marketing. So in this way, it's very much a data-driven approach to allow you to construct a master list, have full access and full breadth of data within that master, but then accurately and reliably and programmatically use metadata to then feed that data into individual outputs that are customized both for the consumption needs and the consumption constraints and restrictions of the data. So in short, use metadata to help you really divide up your data in that way.
Brilliant. So we have already moved to the cloud. What does Tamr work post-migration?
Okay. So I think this comes back to the question about where to build out your mastering pipeline to begin with. So in this case, customers in the cloud, we can deploy cloud natively within your infrastructure. And so then the use of Tamr becomes less about constructing that master to begin with, but maintaining it going onwards. So in terms of sources, we can typically read from those cloud-focused sources such as data lakes or other cloud applications. If there's a master that's already in the cloud, we can use that as a bootstrap to Tamr's processes. So the work you've done in generating that master can be used to help accelerate the creation of Tamr's model. And then in terms of how data is running through this process, if there's systems onboarding data into the cloud, Tamr can pick those up and we can set up a pipeline. So as new data comes in, it can be automatically run through a process and used to construct those mastered records and golden records as well. So in other words, systems can be refreshed even if they're in the cloud or not. So lots of flexibility there.
Perfect. Do you have any relationships with cloud providers?
So yeah, we have strong relationships with the top 3 cloud providers. So for us, that's AWS, Azure, and Google Cloud. So we've got partnership agreements with them, well known within each of those ecosystems as the only cloud native mastering solution for data. And we have a lot of co-sell engagement with them. So often we'll work with our peers on accounts with those teams. But in addition to that, we also have a presence in each of the cloud marketplaces. So this is a really great way to transact with Tamr. So a lot of organizations have their processes set up to procure software and services through a cloud vendor's marketplace. And you can do the same with Tamr. So for example, you can go to the AWS marketplace, search for Tamr, and you'll find all the details there on how to transact with us by clicking through that purchase button. So lots of great ways to interact with Tamr. And of course, we have the support of each of the partner networks with the cloud providers. So we're well integrated and we get their advice and best practices on how to really take advantage of the services they have today, as well as the new ones that they're building out.
Brilliant. We have time for one more. So once you have clean data in the cloud, how do we ensure that it stays that way?
Okay, so we've gone through a process. We've done that movement of data into the cloud. We've decommissioned those systems on-prem and turned off the power to our data centers that were on-prem there. So now we've got all the data in the cloud. There's new data coming in. So we need to put that data through a pipeline, set up a reusable pipeline to refresh Tamr's processes. And this can be done in two methods. Firstly, there's that batch process whereby, okay, new data arrives into, let's say, S3, it's staged there, Tamr reads, runs its process and updates its golden records. But in addition to that, there's also other mechanisms. I mentioned Tamr's RESTful APIs, and those can be used to perform refreshes of data or even data checks on a more interactive basis. So let's say there's a stream of data that's coming through. You could, for example, make a call out to Tamr to say, well, does this customer already exist or not? And have a fast lookup using Tamr's fuzzy matching to identify if that's the case. So the key point is that once you've cleaned your data, you need to stay on top of it to actually make sure it stays clean. And so we provide the mechanisms to cope with data updates to allow you to take advantage of that. And also, once the data's in the cloud, we often find customers are really happy with the onboarding process with Tamr, and they will often get an appetite for integrating new data sources. So it's very much the case that you want to be able to rapidly onboard new reference data or third-party enrichment information. And so that's often a pattern we see as well once people are established with a mastering workflow.
Well, thank you so much for that brilliant session, Ravi. It has been a wonderful experience to be part of this event, and I hope you have found it helpful as well. Thank you so much for joining us, and until next time, goodbye. Thank you so much, Ravi.
Thank you, Larissa. Thank you, everybody, and goodbye.